Hello everyone, welcome to the first video in the pre-calculus series. Now let me ask you guys a question. Have you ever used a vending machine before? It's pretty easy, right? You just put in your money and you press one of the buttons, B2 for example, and whatever snack B2 is assigned to is what the machine will always dispense all the time. Now in math, this is an example of a function. A function is just a rule that assigns every input, so in this case B2, exactly one output, the snack. Now, in a different case, as shown here, the B2 button is assigned to dispense multiple snacks at once. Now, that would be pretty cool to have in real life, but in the world of math, this would not be a function, because one input only gives one output, as stated before. Therefore, this is not a function. So these are the four learning objectives for this video, which I like to call learning aims. So the first aim is to identify a function as a rule with only one output for every input. Second, you should know to use the vertical line test to graphically classify a function. Third, you should use the horizontal line test to identify a function as one-to-one. And fourth, you should know to evaluate functions at various input values. Alright, so now that we have learning aims established, let's dive into some practice problems. Alright, so diving into our first problem, we can see that we're given a table of 4 inputs and 4 outputs. We're asked, given this table of inputs and outputs, is this a function? Now, from what we know, a function takes unique inputs and has only one unique output assigned to each input. Now we can see here that 1 shows up twice in the input column, yet it has 2 different outputs. Now, according to the definition of a function, this cannot be true. So therefore, this is not a function. So for this problem, problem 2, we're asked to use the vertical and horizontal line tests to determine which of these graphs are functions and which graphs are one-to-one. So first, let's start by using the vertical line test. So if I drag this green line across the linear graph here, we can see that no matter where I drag it along the x-axis, it always intersects the graph at one point. Likewise, if I drag this line across the sideways S-curve, we can see that it too also intersects the green line at only one point. However, if I drag it along the ellipse graph, we can see that no matter where I drag it, it will always intersect the green line at 2 points. Therefore, the ellipse that we see here is not a function. Now, if we use the horizontal line test to determine which of these graphs are one-to-one, we can see that no matter where I drag the blue line across the y-axis, the linear graph always intersects it at one point. So therefore, the linear graph is one-to-one. Likewise, if I drag it along the sideways S-curve, once again, we can see that it has multiple intersections with the sideways S-curve, therefore indicating that this curve is not one-to-one. And the same story applies to the ellipse. No matter where I drag it along the y-axis, the graph always intersects it at 2 points. So therefore, the ellipse and the S-curve, or the sideways S-curve rather, are not one-to-one functions. The third problem says, the trajectory of a modeled rocket can be modeled as a quadratic function. Assuming a ground launch, the rocket reaches its maximum height at 1.25 seconds. Define a function h of t to find the height of the rocket at time t. Then, find the maximum height in feet and the landing time in seconds. Assume gravity is negative 32 feet per second squared, or the acceleration of gravity, rather. So, where do we start? First, let's start out by listing our knowns. So we know that this is a general form of a quadratic function. And these are our 3 coefficients. Now, regarding quadratic functions, they can either look one of 2 ways. They can either open down, or they could open up, to give you a visual example. Now, since we're given that gravity is negative 32 feet per second squared, we know that this will be the leading term of the function. So this will be negative 32. And the reason it's negative is because gravity points down in real life. However, another implication of this negative sign is that the shape of the graph will open down, whereas if the leading coefficient a was positive, it would open up. The second thing we know is that the rocket is launched from the ground, so therefore the y-intercept, c, will be 0. Alright, so those are the two of the three variables that we need to know. The third one is b, and we do not know that. Now, an important feature of any quadratic graph is what's called the vertex, and that's the point at which the graph switches direction. Now, no matter where the graph is, either along the x or y axis, the x location of the vertex can be found by this simple formula, and this formula is written as so: negative b over 2a, and that's equal to the x-coordinate of the vertex. This would be something good to write down in your notes. So, how do we find the vertex in this case? We know that the rocket reaches its maximum height at 1.25 seconds. So the vertex x-coordinate is already given to us, because we know that the x-axis represents time. We're going to write that down as a t, and the y-axis represents height. I'm going to write that down as h. So for finding the vertex, and the reason we're finding the vertex is once again to find the coefficient b. So we know that 1.25 is equal to negative b over 2a, and we know that a is negative 32. So if we solve for b, we first need to multiply by a negative, and then let's multiply by the two numbers on the denominator. So this negative will cancel out that negative, and this will cancel out the denominator. So if we complete this calculation, we will find that b is equal to 80. So now we have all three of our coefficients, and we can move on to writing out the height equation in its general form. So therefore, h of t can truly be written as negative 32 t squared plus 80t. And since we know that c is equal to 0, we can basically omit that from the equation. So this is the general form of the equation. Now, we're asked to find the maximum height in feet and the landing time in seconds. So let's start by finding the maximum height. So once again, we know that the rocket reaches its maximum height at 1.25 seconds. So if we plug in 1.25 seconds for t, we can simply plug in that number and find the resulting height. So if we complete this calculation, we will find that h of 1.25 will equal 50 feet. So that will be maximum height. I should label that as part A. So part B then asks us to find the landing time in seconds. Now we know that when the rocket lands, it will be at a height of 0 feet. That makes intuitive sense, right? So Since we know that the height is equal to 0, we then need to solve for the time t at which that happens. So negative 32 t squared plus 80t equals 0. Now, let me just make some space down here. One way we can approach this is by first moving the 32t squared term to the left side, or I'm sorry, this should be a positive. Let's redo that. So if we move this 32t squared term to the other side, this will become positive. So 32t squared equals 80t. And one way we can approach this is to cancel out common terms. So since we have a t on both sides, we can cancel this out, and that will get rid of the squared term on the left-hand side. So then we're going to be left with 32t is equal to 80. Now if we divide this by 32, we can find that t will equal 2.5. So therefore, the rocket will land at 2.5 seconds. And that's problem 3 complete. Now let's move on to problem 4. So this problem asked us to evaluate this function at f of 0, f of 2, and f of negative 1. So this is pretty simple. All we have to do is plug in and find the answer. So f of 0 will simply equal 3 times 0 squared minus 2 times 0 plus 5. Now since we know that if anything is multiplied by 0, the result will also be 0. So that simplifies things for us. So these two terms will go to 0, and the final answer will be 5. Moving on to part B, if we plug in 2 for x, we can write out the equation as so. Now 3 times 2 squared, that is 12, minus 2 times 2, which is 4, plus 5. Now we can pretty easily do this in our heads, right? So we can find that this will be equal to 13, right? If we follow the PEMDAS rule, 12 minus 4 plus 5, pretty simple, right? And so ending things off, we evaluate this function at x equals negative 1, then that will be negative 1 squared minus 2 times negative 1 plus 5. And since negative 1 squared will simply equal positive 1, this will come out to be 3 plus 2 plus 5, which is equal to 10. And that's that problem solved. Alright everyone, so that wraps up today's video on functions, the first video in the pre-calculus series. Thank you all very much for watching, and be sure to like, comment, subscribe, and hit the notification bell so you never miss a new upload. And remember everyone, stay curious.